My name is Trent LaMont, and my position is an Associate Manufacturing Solutions Researcher with a focus on additive manufacturing. This was a reverse engineering project for TEMCO, who is a local manufacturer, and our goal was to use blue light scanning with our ATOS Scanbox and then collect enough information about an assembly of parts to then be able to fully reverse engineer one of the parts.
My name is Evan Waymire. I'm Chief Engineer for TEMCO Engineered Products in Clackamas, Oregon. This is really my first experience with a blue light scanner. And again, that was from the tour that we took back in June. This was part of why I put it in the back of my mind, was this is potentially a great opportunity to have some experience with the blue light scanner and begin to understand its limitations and capabilities.
So the blue light scanner has three lenses on it. One of them is a blue light projector, and the other two are camera lenses that kind of look at the part and they try and come together in one sort of spot, and then they take back the blue light and then through a lot of math turn that into digital data.
So Trent swung by TEMCO last week and picked up the parts so he gave a chance to look at them and do some initial fixturing. And so by the time I arrived this morning, he'd already, there were three parts he was scanning. He already completed the scans on two of them. And so we were really down to the third part, which was the most difficult, most critical part. So he had it all ready to go. He had the third part on the stage, had the little dots affixed to it.
Our whole goal for the project was to get measurements of this component that were as accurate as we can really possibly get. We got enough data to be able to make informed estimates for reverse engineering purposes. Because this was a plastic component that was likely injection molded, it's not a very geometrically stable component. So we were also able to see kind of how round it really is and how flat certain aspects of the part really are, so that they can get a better estimate when they're trying to machine this component, just how important those sorts of things are, which then helps them better predict cost of their final part. To me, this project stands out because we're working with a small to medium enterprise, which is a goal that OMIC has. We are helping take a part that has been manufactured one way because that's the way we've always done it, and then move that to a new process that's better suited to the purpose of the part. There was a great level of collaboration on this part. We were able to have them out on site while we were measuring to better kind of inform our decisions around how are we going to do this, what's important, what's not. And I think on our projects, sort of the best ones are the ones we can have the best communication on. And so that as we're working through something, somebody can ask questions in real time instead of finding out a week later that something happened.
Everybody's been easy to work with. You fit us into our schedule in a timely manner. So yeah, I've been, so far it's been a seamless organization to work with.